Huawei is very dangerous.
Rarely does a country go to war with a private company.
We have met the enemy, and it is Huawei.
We're not going to do business with Huawei.
Huawei represents a national security risk.
But is this really about Huawei, or is it something bigger than that?
Huawei has confirmed testing of a homegrown EUV machine that could rewrite the global semiconductor game. This is the tech bombshell you didn't see coming, and it's unfolding right before our eyes. For years, the West, led by giants like TSMC and Intel, has dominated the semiconductor space with EUV, the holy grail of chipmaking tech that powers the most advanced chips. China has been locked out of this club, with experts saying it would take them a decade, maybe 15 years to catch up. Well, guess what? They're not waiting that long. EUV, or extreme ultraviolet lithography, represents the pinnacle of semiconductor manufacturing technology. It enables the creation of the smallest, most powerful chips that drive everything from smartphones to artificial intelligence systems. The Western world has held this technology close, with ASML, a Dutch company, standing as the sole manufacturer of these sophisticated machines. Each EUV machine represents decades of research, thousands of precision-engineered components, and a price tag exceeding $350 million. This wasn't just expensive equipment. This was the foundation of modern technological superiority, the key to unlocking the future of computing, and the West's trump card in the global tech race. But here's where the story takes a dramatic turn. In 2019, the US hit Huawei with sanctions, cutting them off from American tech and advanced chip tools. ASML, under pressure, stopped shipping EUV machines to China. Huawei's chip-making partner, SMIC, was stuck with older DUV tech, which maxes out at 7 nanometers. DUV, or deep ultraviolet lithography, is the previous generation of chip-making technology. While capable, it has physical limitations that prevent it from producing chips smaller than 7 nanometers efficiently. China's tech dreams looked dead in the water. The sanctions appeared to have worked perfectly, cutting off China's access to the critical technology needed for advanced chip production. Industry analysts, semiconductor experts, and Western policymakers all agreed. Without access to EUV technology, China's chip ambitions were effectively dead. The technology was too complex, too sophisticated, and too deeply embedded in a Western-controlled supply chain. But instead of folding, Huawei and China doubled down. They poured billions into R&D, rallied their brightest minds, and started building their own EUV ecosystem from scratch. This wasn't just about survival, it was about defiance. The Chinese government mobilized resources on a scale rarely seen outside of wartime efforts. Universities, private companies, and state-owned enterprises were coordinated in a massive push towards semiconductor independence. Xi Jinping made self-reliance a national mission, identifying semiconductor independence as a core national security priority comparable to food security or energy independence. And now, in 2025, we're seeing the payoff. Reports have exploded across the tech world. Huawei is testing a homegrown EUV machine at its Dongguan facility. Trial production is slated for the third quarter of 2025, with mass production eyeing 2026. This isn't a rumor, it's confirmed by credible sources. China is pulling off what many thought was impossible, and it's all tied to a mysterious 3-nanometer plan. The implications are staggering. If successful, this would represent one of the fastest technological leaps in semiconductor history. But how exactly did they pull this off? Enter LDP, laser-induced discharge plasma. It's a different beast from the laser-produced plasma that ASML uses. LDP vaporizes tin between electrodes, zaps it with a high-voltage discharge, and turns it into plasma that emits EUV light at the exact sweet spot for etching tiny 3-nanometer circuits. The physics behind this approach differs fundamentally from ASML's method. While ASML uses high-powered lasers to blast tin droplets into plasma, the LDP method employs electrical discharge between electrodes. This creates the same 13.5 nanometer wavelength light needed for EUV lithography, but through a different mechanism. It's simpler, smaller, and cheaper than ASML's hulking LPP machines, which cost over $350 million a pop. The potential cost advantage cannot be overstated. If Huawei's approach works at scale, it could produce EUV machines at a fraction of the cost, fundamentally disrupting the global semiconductor equipment market. This LDP-based EUV system is already in testing at Huawei's Dongguan site. A Chinese firm, rumored to be China's lithography champ, filed a patent for this tech in 2023, and now it's coming to life. If it works, mass production in 2026 could flood China with homegrown 3-nanometer chips, smashing the sanctions wall to pieces. But wait, there's more. This isn't just about Huawei. SMIC, China's top foundry, is in on this too. Together, they're not just catching up. They're aiming to leapfrog the West. A South China Morning Post report highlighted a Harbin team's EUV light source breakthrough, also hitting that 13.5 nanometer mark. This is a coordinated push, and it's moving fast. Multiple research teams across China have simultaneously achieved breakthroughs in different aspects of EUV technology, light sources, optics, and lithography systems. The coordination suggests a well-orchestrated national strategy rather than isolated research efforts. Huawei's new Shanghai R&D campus is hiring chip veterans to build lithography machines from the ground up, investing in long-term infrastructure that signals they're in this for the long haul. Why does 3 nanometers matter? Simple. Smaller chips mean more power, less energy, and insane performance. Your next phone could run AI models on device. Cars could drive themselves flawlessly, and quantum computing could get a massive boost. The difference between 7 nanometer and 3 nanometer chips is exponential, not linear. A 3 nanometer chip can pack nearly twice as many transistors into the same space, dramatically increasing processing power while reducing energy consumption by up to 30%. The West's lead here has fueled everything from NVIDIA's AI dominance to Apple's iPhone empire. If China cracks 3 nanometers, they're not just in the game. They could rewrite the rules. If Huawei and SMIC nail this, ASML's monopoly crumbles. China's cheaper homegrown EUV system could flood the market, undercutting ASML's $350 million behemoths. The US sanctions have backfired. Instead of crippling China, they've lit a fire under their tech sector. Huawei's founder told Xi Jinping in February 2025 that chip shortages are easing. This statement, coming directly from Huawei's leadership to China's president, signals confidence in their domestic chip production capabilities. NVIDIA is even warning investors about Huawei's AI chip gains. When NVIDIA, the world's leading AI chip manufacturer, publicly acknowledges a Chinese competitor's progress, it validates the threat level. ASML's CEO said in December 2024 that China's 10 to 15 years behind without EUV. Well, that gap is shrinking fast. SMIC's 7 nanometer output for Huawei's AI chips already shocked the world. In 2023, when Huawei released smartphones powered by 7 nanometer chips, despite sanctions, Western analysts were stunned. The chips, manufactured by SMIC using advanced DUV techniques, demonstrated that China had found workarounds to technological barriers. If 3 nanometers hits in 2026, that timeline's toast. But here's the flip side. China's still years behind on scale. ASML's ecosystem took 20 years to perfect. Huawei's LDP tech is promising but unproven. Trial glitches could delay mass production, and even then, yields might lag TSMC's polished process. Manufacturing semiconductor equipment at laboratory scale differs vastly from mass production. ASML's machines achieve yields exceeding 90%, meaning more than 90 out of every 100 chips produced meet quality standards. Huawei must match or approach these yields for commercial viability. Building a full EUV supply chain, mirrors, lenses, software, is a Herculean task. China's betting big, But the jury's out. The West's not trembling yet, but they're watching. This isn't just about chips, it's about sovereignty. China's tired of relying on the West. This is about technological self-determination, reshaping global power dynamics, and potentially ending the Western technological monopoly that has existed for decades. The Chinese government has made it clear that semiconductor independence is non-negotiable, a matter of national security that ranks alongside food and energy independence in strategic importance. So, where does this leave us? Huawei's EUV trial is confirmed, the 3-nanometer plan is real, and China's charging toward a tech revolution. Will they topple the West? Too soon to tell, but one thing's clear. The game has changed. This isn't a David versus Goliath story. It's Goliath learning to fight back with a slingshot he built himself. By the third quarter of 2025, we'll know if this machine's the real deal. Until then, the world's holding its breath. The next 6 months will determine whether China achieves technological independence or faces another setback in its semiconductor ambitions. Either way, the global tech landscape will never be the same. Do you think China will successfully mass-produce 3-nanometer chips by 2026, or will they face insurmountable technical challenges? Drop your thoughts in the comments below, and don't forget to subscribe for more breaking tech news that's reshaping our world.